Okay, so this is the 2024 Higher Level Maths Leaving Cert Deferred Paper 2, Question 9a, Part 1. The scattered plot below shows the height and weight of each player on a rugby team in meters and kilograms respectively. So we have our graph here and we have our scatter plot up along here. One of the numbers below is the correct correlation coefficient for the data above. Put a tick in the correct box to show which one is the correct value. Tick one box only, justify your answer. So we have 0.4 which is positive, 0.9 which is positive. We have 0.3 and 0.8 which are both negative. This is a positive correlation, so it can't be the second or the fourth one. So it's either 0.4 or 0.9. Now this correlation here is quite strong, so it's not going to be 0.4. The answer will be 0.9. So I'll put a tick there. The justification then is just going to be there is strong positive correlation. That's really it for part 1. So part 2 here just says, on the scatter plot above, draw the line of best fit for the data by eye and use the line to estimate the weight of a rugby player that is 1.8 meters tall. So I put in my line of best fit here and I have started over here at 1.8 meters tall. You would need to use a ruler here and come down along here. And it looks like I'm getting 90 is halfway, so I'm getting about, let's say, 91 kilograms. So my answer to part 2 would be 91 kilograms. Okay, so this is part B. The particular rugby team usually miss 8% of the tackles that they attempt. Use this fact to answer parts B1 and B2. Assume that all tackles are independent. Give your answer correct to 4 decimal places. So in part 1 we've got to find the probability that the fourth tackle in the game is the first one that is missed. Okay, so I'm going to do this two ways. I'm going to use the Bernoulli trial method first, which is kind of the more complicated way of doing it. But we want to find the probability that the fourth tackle in the game is the first one to be missed. So I'm going to take P as missing, which is the probability of success, if you like, in this procedure. So it's 0.08. Q then is the probability of failure. That is 0.92, so that's the probability of making the tackle. So we want the first 3 tackles to be made. So in other words, we don't want any, we want 0 misses. So remember, P is the probability of success. So we want 0.08 out here. Then we want to raise that to the power of 0. We want to multiply that then by the probability of failure. In our case, it's 0.92. which we raise to the power of 3 minus 0. So this represents the first 3 tackles. It represents 0 successes in the first 3 attempts. So successes is a miss, so we have 0 misses in the first 3 attempts. Now the fourth tackle then has to be a miss. The fourth tackle is the first one that is missed. So missing has a probability of 0.08. Now when you do all of that, then you get 0.0623. Okay, so that's the first way of doing it. The simpler way of doing that is just to look at it tackle by tackle. So we want the fourth tackle to be the first one that is missed. In other words, the first tackle needs to be made. The probability of the first tackle being made is 0.92. The second tackle being made is also 0.92. The third one is 0.92 because these tackles are independent of each other, as we're told in the question. And then the fourth tackle is the first one that is missed. So that's 0.08 out here. So you can see that that's exactly the same as what we've done up here. It's 0.92 to the power of 3. That's this part here. This is all just 1. 3 choose 0 is 1. 0.08 to the power of 0 is 1. And then we have our 0.08 out here at the end. So we get the same answer. Okay, let's have a look at part 2. Find the probability that the team miss at least 2 tackles out of the first 20 tackles that they attempt in a game. The probability that the team miss at least 2 tackles is going to be 1 minus the probability that they miss no tackles plus the probability that they miss 1 tackle. Now you could do this the long way as well. You could do the probability that they miss 2, they miss 3, they miss 4, all the way up to 20. That's going to take a long time to do. This is the way you would be expected to do it here. So let's do it anyway. We've got 1 minus the probability that they miss no tackles. So again, it's 20, choose 0. They're going to miss no tackles. So remember, the probability of missing is 0.08. That's to the power of 0. The probability that they don't miss is 0.92. So that's 20 minus 0. Plus the probability that they miss one tackle. So that would be 1 here. 20 choose 1. 0.08 to the power of 1 times 0.92 to the power of 20 minus 1. So this is all just calculator work then at this stage. So this is equal to 1 minus the probability that they miss no tackles is 0.188693392. The probability that they miss one tackle is 0.32816231116. So add these two, subtract from 1. So we have to do this to 4 decimal places. So that would be equal to 0.4831. Okay, let's look at part C. At a particular stage of the game, this rugby team will score either 7 points, 5 points, or 0 points. The probability of each of these is X, Y, and Z, respectively, where X, Y, and Z are real. So to score 7 points, the probability would be X, to score 5 would be Y, to score 0 would be Z. The probability of getting 7 points is 4 times the probability of getting 5 points. The expected value of the number of points is 1.155. Work out the value of Z, the probability of scoring 0 points. Okay, so let's just write out that table again. We'll take the points are going to be 7, 5, or 0, and the probability then is Y for 5 points. But the probability of getting 7 points is 4 times the probability of getting 5. So this would be 4Y here instead of X. We leave Z there. So let's write down the expected value. So the expected value is 1.155. That's equal to the probability times the number of points. So it's 4Y times 7 plus Y times 5 plus Z times 0. Now if you just simplify this, you get 1.155 is equal to 28Y plus 5Y plus 0 here. So that'll give us, let's see, 1.155 is equal to 28Y plus 5Y, that's 33Y, and then finally Y is equal to 0.035. So now we know the probability Y. So let's just write down our probabilities. The probability of 7, the probability of a 5, and the probability of a 0. So the probability of 7 is 4 times Y, it's 4Y. So you've just got to multiply this by 4. That'll give us, let's see, 0.14. The probability of 5 is just Y, so that's 0.035. And then the probability of 0, Z in other words, this is Z here, the probability of getting 0 is going to be 1 minus 0.14 minus 0.035. So probabilities add up to 1. So these three probabilities have to add up to 1. So subtract these two from 1 to give us Z. When you do that, you get 0.825. So this is our answer. This is the value for Z, the probability of scoring 0 points at this stage in the match. Okay, so that's part C. Okay, let's look at the next question. The coach of the rugby team must pick 3 forwards from a total of 7 possible forwards. How many combinations of 3 forwards can the coach pick? Well, that's just a case of 7 choose 3. You're choosing 3 from a total of 7. So that's, again, just calculator work. You get 35. Okay, this is the last question. On Saturday, the coach picks 3 forwards at random from the 7 forwards. On Sunday, the coach again picks 3 forwards at random from the same 7 forwards. Find the probability that no forward is picked on both Saturday and Sunday. So he picks 3 forwards on the Saturday, leaving 4 forwards that he can pick from on the Sunday, because the first 3 forwards that he picked on the Saturday can't play on the Sunday. So he has 4 forwards to choose from on the Sunday, and he has to pick 3 from those 4. The number of ways of doing that is 4 choose 3. Now the probability that this will happen is this number here divided by the total number of ways of picking 3 forwards from 7. 7 choose 3. So when you do this, you get a probability of 4 over 35. So the probability that no forward is picked for both Saturday and Sunday is 4 over 35. That's it for this question.